Well, hello and welcome you to Mr. Robinson back here with yet another brand new exciting video. All math physics course, and as always, it's an honor and privilege to be serving you here today, as it is every day here in my virtual classroom. Step one inside as we conclude Chapter 1 in the Big Ideas Math Integrated Math 3 textbook. We are bringing it all in, the Chapter 1 test and cumulative assessment. I'm going to break up the PDF into two different PDFs, break it up into two parts. The Chapter 1 test description section down below, and the cumulative assessment right down below as well. Find timestamps for each corresponding part and problem. If there are any things with graphs, you can also download graph paper stuff with that as well. So I'm going to jump right into it, guys. This is, if you want some more questions that are cumulative with Chapter 1, you can take a look. And as this says cumulative assessment, it's cumulative to the book, but book we've only done Chapter 1 with. But if you want more of this stuff, go to the Chapter 1 review video that's already been made for us from before. Okay, I'm going to go ahead and jump right into it. Probably get your calculators ready. A lot of things where, if anything, we've got to multiply by pi and round. Let's start this off with number 1, the island shown. It's a triangular island. Looks like a right triangle by that symbol. The island shown has a population of 12,175 people. And find the population density in, whoops, something popped up, in people per square kilometer. Now we have kilometers there. We are going to have to find the area of the island. Now in this island, we do have 11.1 kilometers as one of the side lengths, but this hypotenuse is 18.5 kilometers. It's not one of the values you need for area, though. We need to find this value here to get area. We need to do 1/2 of this times this, so 1/2 base times height, if you will. Not this number, but we need to use Pythagorean theorem to get that. So x squared plus 11.1 squared equals 18.5 squared. We have to get area. And population density is number of people over area of land. So we're getting that area to begin with. So x squared plus, I don't know, I'm already using the calculator, 11.1 squared. I look at this problem and I go, so this is how the chapter test is going to be, huh? One of these things. I think sometimes they really do ask a little bit more of you on these kinds of questions. They're not always most basic. And this is really saying, how much do you know? And I might have more doing, less teaching on these if I feel like it's going to take quite a while to make happen. So x squared, and I am doing 219.15, so x is the square root of that. I'm not going to round it. I'll just leave it like that. I'm sure there's no simplification to be had, but that's kilometers. Okay, so that's that guy. So area of this triangular land, of this island, area is 1/2, base times height, or whichever way. Base, you can identify one way or the other, but you don't use 18.5. Okay, so we use those ones together. So again, probably no rounding yet. I'm going to have a number. 1/2 of 11.1. I should have known that, 5.55. So area is 5.55 times the square root of 219.15 square kilometers. I know that's weird. I just don't want to round yet because I'm going to use this in my calculation. Now I want to make sure it rounds to the right density value we're looking for. Now density, once again, is number of people divided by area of land. Number of people we have is 12,000, and let me write that. Population is 12,175 people. So density is 12,175 divided by this area. And I don't know what this area approximates to at all. I'm not really worried about that. I'm going to let my calculator take care of that. This is number of people per square kilometer, which is what they're asking for. So we'll do 12,175 divided by, I'm using my calculator here, you can check it out. I'm using 12,175 divided by 5.55 root 219.15. So a lot in the cards here. And we're getting 148.18. Now, I'm going to round to the nearest person per square kilometer. So I'll say 148. 148 people per square kilometer on this island. I don't know if that's a lot or a little. It is an island. Say hi to your neighbor. Love thy neighbor. And we're all good. That's number 1. Number 2. You slice the bagel shown in half horizontally. Excuse me when I clear my throat. I've kind of been doing a lot of these videos. You slice the bagel shown in half horizontally to split with your friend. Describe the shape of the cross section you make. What does the cross section look like if you cut the bagel half vertically? Now, this would have been out of section 1. Let me try and do sections by number. This is section 1.1. This would have been out of section 1.3. And trust me, I'll forget to do this at some point. So cutting it in half like that is going to look like this here. You know, you're cutting there. And you ultimately get just the appearance of what, when you slice a bagel, right? This is a perfect analogy. People slice bagels all the time. Slice a bagel in half right there and look at what you see from top down. What is that? It looks like 2 concentric circles. It looks like a circle and another circle that, there's the hole, right? Here's the bagel itself. Here's the food. But it looks like that. It looks like 2 concentric circles when I'm looking at it from the top down, when I'm looking at the 2D representation of my cross section. That's literally, I never use that as a reference, but that's literally what a cross section is that everyone's seen before. What does the cross section look like if you cut the bagel in half vertically? Well, vertical is a different story. See, that's me slicing like this, slicing, and kind of out comes that. And that's the important part, right? Just what's the appearance of the cross section that you see? When you slice, what's the part that's sliced? That would just be, and this will look kind of weird, that would just be 2 circles. It would be this one and this one. Imagine the rest of the bagel is, out here, right? That's the rest of the bagel. But that doesn't matter. What matters is the cross-section portion here and here. So a vertical cut is just 2 separate circles. 2 congruent, probably. 2 separate congruent circles. I think my calligraphy pen style I got rid of that. Let me get that back. So that would be the 2 different drawings that you'd have, whether it's horizontal slice and vertical slice. Clearly different ones together. All right, numbers 3 and 4, we're going to rotate these things. This is out of section 1.4. Let's get that out of the way now that I know it's there. Sketch and describe the solid produced by rotating the figure around the given axis, then find its surface area and volume. Oh, I'd have a lot to say on surface area here. They're really actually challenging you on some of these things. Surface area has a little bit to talk about. I don't want to, spend a whole lot of time talking about it, and I'll save surface area for last. First things first, rotating this thing around, that radius of 3 comes over on this side here. We get this top cylinder, if you will. Top cylinder. And then this other one, not right there. Well, yeah, you do. This radius of 3 goes here as well, so I got a whole top cylinder. And then I get a bottom cylinder here, which does go there and rotates around the other side. That is a radius of, I think, 6, it looks like. Goes around the back. Hopefully you can tell what we're doing with the drawing. It probably is easier to see without the object. Maybe I get to remove the object afterward. See if you like the appearance more. Because I think I'll complete this drawing in full beyond that. So take a look if this makes sense to you without the original drawing. If I just move this out of the way. So do we understand what we're looking at here? You see that? It's like a drum, I actually might draw it like that, but let's do this. Let me copy paste it so I get 2 of them. I get this one and that one there. Sound good? So there's the original. I'll keep that in mind, the rotation of these things. Now here's the drawing when I place it upward like that. I want to show you this for a couple. I think you can see it better. So I have a radius here of 3. I have a radius here of 6. I have a total height of 10. So this height is 7. I don't care about the total height. I care about the individual heights. So if the total height's 10, that means this one's going to be 3 right here as well. So hopefully I've made everything out of that I need from it, right? Total height's 10, that guy's 3. So this is a square that got rotated around, and that's a rectangle, is 6 by 7. Okay. Describe the solid. So the solid is 2 cylinders. One smaller than the other, but 2 cylinders. They say find the volume and surface area. Now volume's going to be fine. I add the 2 individual volumes and I'm all set. Surface area, kind of a different story. We'll see why in a moment. But let's move this as far over as we can. So call it object 1 and object 2. Okay. So volume of object 1, volume of a cylinder is area of base times height. So pi r squared times height. That'll give you 27 pi cubic units. Volume of object 2 is going to be area of base, pi r squared times height. 36 times 7 is 252. 252 pi cubic units. So when I add those together, I get volume of total, which is going to be 252 pi plus 27 pi, which is 279 pi cubic units. When I use the calculator and round, I get 279 pi 876.50, if I do to the nearest hundredth, 876.50 cubic units. Now, surface area is going to be a different story because although there's a surface area formula that we're going to be using, right, what we do need to do is understand that this part is covered. I guess it's not going to be too hard, but this bottom part is not only covered from the bottom of object 1, but it's covering the top of object 2. So listen, as a whole, I could find the surface area of both individually. Find the surface area of the bottom, surface area of the top. But then I got to do a subtraction of two things. I got to subtract this circle twice. It's not included in the top surface area at all. And it's taken away from the bottom surface area as a whole. So that's one that, yeah, we can, I suppose we can work it out that way. Let's give it a shot. So maybe I'll just copy paste this over to the next page because I want to see the visual of it. There's a lot of ways we can talk about that. We'll see which one you most prefer. So, still object 1, object 2, right? Surface area, this is still number 3. Surface area of object 1 as a whole would be circumference times height, that's lateral area, plus, do we want to do the area of both? How about this? How about we just do the area of the top, the pi r squared? So I've already removed one of them. As far as surface area of the top, it's the parts that's exposed to the top. So object 1 there is going to be, so circumference times height, so 9, 18. So 18 pi plus 9 pi, which is 27 pi square units. That's the top guy of all the stuff that is you can see. Now the bottom one, I'll go ahead and take away that thing from the bottom one in just a moment here. We'll do circumference times height plus area of both bases. Okay? And then we will be subtracting the area of that base right here. This is going to be taken away from the top base area there, right? The top circle, take away that circle. So I know it's interfering with the drawing. I apologize for that. Hopefully you can see me progress through the problem and kind of be okay with it. So surface area of object 2 is 7 times 6, 42, 84. 84 pi plus 72 pi minus this 9 pi. And then we'll add the total in the end. Then we'll be done. 84 minus 9 is 75. 75 plus 72 is 147. So I get 147 pi square units. So now we get to add the two together. Surface area of the total will be 27 pi plus 147 pi, which should be 174 pi square units, which is about 546.64. 546.64 square units. So, you know, it depends on how you want to work out how you excuse me, how you configure the area stuff. I did end up just saying what was exposed for 1 and 2 and just added them in the end, or you could have subtracted the circle area twice. It's kind of your call, but that should be the final answer there. A little tricky, something we haven't really done so much of when it's the same thing. Well, number 4 has that same concept. The difference is this will be shared. I don't know how to explain it right now, but that circle area is the same for the top cylinder and the top hemisphere and the bottom cylinder. So we're going to do another rotation. So go around this guy here. We got a hemisphere on top, like so. It's got a radius of 3. This thing also has a radius of 3 of this bottom cylinder, so that's cool. It's going to have the same thing for those. Cylinder has a height, though. So we have a hemisphere and a cylinder. Both of them share a radius of 3. That height of 9 really is irrelevant to me because this is a hemisphere. All I care about is its radius. That's still 3, and that makes no difference to me. They give me that this is 6, and that's all I care about. It would have been much more interesting if they didn't give me that 6. We would have said this is 3 based on radius being hemisphere. That's 9. 9 minus 3 is 6. But they gave us 6, so we're good. So if this is object 1 and object 2, we need the height of object 2, and that's going to be 6. So let's do the volume and surface area of both of these. Let's find the volume of object 1, the hemisphere. Instead of 4/3 pi r cubed, we'll be doing 2/3 pi r cubed. It's because it's a hemisphere, half of it. 3 cubed is 27, divided by 3 is 9. 9 times 2 is 18. So we get 18 pi cubic units for object 1. Object 2 is area of base times height. We got pi times radius squared times 6. 3 squared is 9 times 6 is 54. We get 54 pi cubic units there. And the volume of the total will be, will be 18 pi plus 54 pi. Look at that. No calculator needed thus far. Now we need the calculator. 72 pi. It's going to be around 225 or so. 72 pi. 226.19. 226.19 cubic units. Volume of this thing. Of this BB-8. No, of this R2-D2. Sorry about that. Very sorry about that. I was very sorry about that. Don't hate me. All right. I don't know why I said BB-8 first. Surface area. Surface area of object 1. Now here's the thing. It's just the top hemisphere. The circle is covered, right? That bottom circle is covered. So I just need the 2 pi r squared. So 2 pi times 3 squared. 3 squared is 9 times 2 is 18. We also get 18 pi here, but it's square units, not cubic. So there's object 1. Object 2, the top circle's covered. So we just need the bottom circle with the lateral area. So surface area of object 2, its circumference times height plus just one base area, pi r squared. Not 2 pi r squared, it's just 1 pi r squared. So we'll get 36 pi plus 9 pi, which is 45 pi square units. So surface area of the total will be 18 pi plus 45 pi, which is 63 pi square units as an exact, as an approximated. It's going to be close to 200. 63 pi. 197.92. 197.92 square units. So once again, the base, the circle was covered on bottom and on top. It's not exposed to the overall surface. Kind of the same thing as we had from the other. I think that one's just easier to see because it's the same circle on top and bottom that we're removing. Now, I never truly removed them. I just never added them. It's kind of an up to you thing. All right, that was numbers 3 and 4. Let's go to numbers 5 and 6. Describe how the change affects the surface area of the regular pyramid or right cone. It's just surface area, not volume. We're going to triple all the linear dimensions of what we have. Now, this must be an equilateral triangle pyramid thing because otherwise we couldn't gauge that slant height for what it is. And that is a slant height on number 5. Let me copy paste that. Tripling all the linear dimensions. So that's not the height of the pyramid. It is a slant height. Notice that right angle is going to the base edge. And that's why I said this is going to have to be equilateral. So this divides that in half. That doesn't matter, but this divides that in half there. It's going to that. That is L. So L is 4. There is stuff we have to do with the base area, though, because that's part of your stuff. Now, this is the first time we're doing surface area of a pyramid. I haven't done it with you yet in this book. So I'll talk about how we get that in a second. But slant height's used. Slant height's used in it. Now, we will need the base area as an eventuality. So on the bottom, and they never really make mention. Oh, they do say regular pyramid. Okay, so it's an equilateral triangle. Cool. I mean, I knew it was, but I didn't know they told us. I said, that's a very far assumption they're making with that. Just like the triangle on number 1, we need a height for this base length of this triangle on bottom, right? That triangle on bottom's here. We need this height. I guess we do need to know this divides this in half. So 2 meters divides to 1 meter, and this becomes a 1 to 2 to root 3. This is root 3 meters for that. So your area of your base is 1/2 base times height. Half of 2 is 1, you get √3, and that's √3 square meters. I know I'm going fast. I intend on having you know how to find things with triangles, 30, 60, 90 triangles. By the way, this is equilateral. I kind of mentioned that before, but these are 60s, therefore, and this is 30. It makes it a 30, 60, 90 triangle. I didn't mention that. I apologize. You can pause and take a look at that, but that's area of base. Now, I didn't go any farther for you than this here, but your surface area of your pyramid is your lateral area plus your base area. Lateral area is all 3 of these triangles that you see that make the pyramid here. 1, 2, and the back one, 3. And they're all congruent to each other. The formula for lateral area of a pyramid is 1/2 perimeter of your base times slant height. Perimeter of the base is 6. 2 plus 2 plus 2. Slant height they show you is 4. L is 4. So that's your surface area. This is the first time we're doing pyramid. Suddenly, right in the chapter test, boom, they're saying, all right, figure it out, which is interesting. I'm sure there are other things you could do. If you know it's regular, you know there's a congruent, you can find other ways of getting it. Half of 6 is 3. 3 times 4 is 12. You get 12 square meters there. So surface area is going to be lateral area plus base area. Surface area is 12 plus square root of 3. That's not 12 root 3. It's 12 plus square root of 3. And square root of 3 is around 1.7-ish, but I want to be sure. 12 plus square root of 3. So 13.73. 13.73 square meters. Now, there's also this exact answer, and I think I still need it because this is object 1. We still have to triple, is that what they said? We still have to triple all the dimensions. Now, I'll give you what the answer is as well here before we actually get to the next part. This is object 1. This is object 1, object 1. Excuse me. Object 1, object 1, object 1. All right, so that's all object 1 stuff, right? Now, object 2 is if I triple everything. So it's not going to be much I got to do beyond that. Understand what will be tripled here and there and everywhere. This will become 3 root 3 and 6, and not too bad. Now, when I come up with the final answer here of surface area 2 over surface area 1, because we're talking about surface areas and we're tripling everything, we got to square 3 basically. We're going to get 9. 9 times bigger. That'll be the final answer. We got to do 3 squared, right? 3 squared. But, let's calculate the other surface area. Let's get to it. So surface area of object 2 will be the lateral area plus the 2 base areas. I'll kind of save that for the bottom. Let's first get the base area. Base area of object 2 is 1/2. Base, the original one was 2, tripled to 6, times height, the original was 3, now it's 3 root 3. Or root 3, now it's 3 root 3. Half of 6 is 3, 3 times 3 is 9. We get 9 root 3 square meters of base area. Lateral area, it's 1/2 perimeter times slant height. The original base lengths were 2, now there's 6. 6 tripled is 18. Slant height was 4, now it's 12. Half of 18 is 9. 9 times 12 is 108. We get 108 square meters. And the surface area of both of those added together. So we're going to do 108 plus 9 root 3 square meters. Rounded. Not that I think we actually need that one, but 108 plus 9 root 3 is, we're only at number 5, 123.59 rounded. Now, what do you venture the guess is of what 123.59 is divided by 13.73, or this divided by that, right? So surface area, I'm kind of running out of space on the bottom there. Surface area 2 divided by surface area 1. And listen, I'll even use the rounded values. It's not going to be exact, but you're going to see how close this is to 9. 13.73. Maybe a little bit more than 9 based on my rounding. Let's go to the calculator. Let's see. Whoops, you can't see my calculator. 123.59 divided by 13.73. 9.00, right? This is supposed to be 9. I rounded my numbers, but 9 times more. 9 times bigger than it was before. And that's what we're getting on that guy. So that is number 5 when you triple them all. And again, I don't know if we're allowed to just say 3 squared. I think we do have to do all the computations, and it's kind of good we're doing that. Or maybe we don't. Maybe that's why they gave us a pyramid that we've never done a surface area for before, because you just got to know to just square your scale factor. All right, let's do number 6. But I will continue doing that. I want to practice those things with you. Maybe you have to do it, and I have to cater toward that. The book never really said. We explored it, but it never really said. And that's true of the review as well. I had to say the same thing on the review. Multiply all the dimensions by 2/3. So all of them doing surface area here again is going to leave us with, ultimately, we got to do a k squared there, right? Surface area of object 2 over object 1. We're going to be doing 2/3 squared, which is 4/9. This will be the final answer there. If you want to move on, go ahead. I'm going to do surface areas of this thing. Surface area of object 1, the original cone. We have everything we need. This is slant height. This is radius. We don't need to find the height itself, not for surface area. We're going to do pi r l plus pi r squared. This is lateral area plus the base area. I need my calculator though. So 2.4 times 3.6 is 8.64. So I have 8.64 pi. That's a plus, not a pi. 8.64 pi plus, and that's 5.76 pi. Ooh, that's kind of clean. Not fully. 14.4 plus 5.76. 14.4. So 14.4 pi square feet as actual surface area. If you want to round it, I mean, listen, I don't feel rounding is necessary for us. We're going to be doing a division of this thing here. I shouldn't have rounded the other one, but it had the roots, the radicals added. It was kind of weird. So that's the object 1. Now object 2 is going to have 2/3 of these. So let me just write them here. 2/3 of my slant height, 3.6, is going to be 2.4. And then 2/3 of 2.4 is 1.6. So these are the numbers we're going to use the new slant height, L2 and R2. So let's do the same thing. Now we should end up getting 4/9 of the thing when we do everything all told. But surface area of object 2 is pi RL, so 1.6 and 2.4, plus pi r squared. 1.6 times 2.4 is 3.84. So 3.84 pi plus, that's 2.56 pi, which again should kind of clean up. Is that 6.4? 3.84 plus 2.56. 6.4. So we get 6.4 pi. And I won't round that one either. I'm just going to leave it. So 2 over 1, 6.4 over 14.4. SA2 over SA1 is 6.4 pi over 14.4 pi. The pi's will cancel, and this should be exactly 4/9. Now 4/9 is 0.4 repeating. So when I go to my calculator, I'm going to be doing 6.4 divided by 14.4. Do we get 0.4 repeating? Yes, we do. And a fraction equivalent, 4/9. So we get 4/9 times what it was. That was the predicted answer. That is the answer. We got our surface area stuff down. Good old practice of it all told. Excuse me. Let's keep going to number 7, 3 parts. The candle has a mass of 1,200 grams. So this candle this candle right here. This candle right here. Part A, what is the density of the candle wax in grams per cubic centimeter? So we have inches. Okay, first of all, let's do a straight conversion now. 1 inch is 2.54 centimeters. That means we have to take this candle and we got to multiply these numbers by 2.54. I'm going to copy paste the candle, the cylinder. We're going to come up with these numbers, not as inches, but as centimeters. I'm going to do that with my calculator. What was a decimal before stays as a decimal now. 8.5 times 2.54 and 3.5 times 2.54. We are getting centimeter values of exactly, don't round it, 21.59 and 8.89. Okay, because they talk about density in terms of grams per cubic centimeter, we need to find out and we have 1,200 grams of mass. Okay, full disclosure, I started to do the problem, and then I was like, oh, hold on a second, I need to, I didn't change, this is diameter, so I need radius from this thing. So I'm going to divide this number by 2. We're going to divide diameter by 2, and we're going to get radius. So R is 4.445. So kind of, there's a lot we're going to have to do here, guys. Okay. Yeah, this is a chapter test, man. It's robust. Totally. So density for a candle is mass over volume. And we have the mass as 1,200. We still need the volume. Volume is area of base times height. Pi r squared times height. Remember, we need this in cubic centimeters. So that's why we converted. That's what we're going off of. So 4.445 squared times 21.59. I can't believe the decimal. I can't imagine the decimal thing's great. I don't even know if this is an exact number or if I lost decimals along the way. But 426 point, there's a 5757598. I'm just going to write 58. Oops. 58 pi. There's more to it than that I'm going to use in the calculator. Don't worry about that. But density being mass over volume, we're going to do 1,200 over that number, 426.58 pi. And then we come up with the value. So I'm going to go to the calculator for that. We'll do, see, there's the number. But 1,200 divided by the previous answer times pi. Okay, so 0.8954. All right, 0.895. I don't really know how many things they want. But 0.895 grams per cubic centimeter is what I'm getting off of that guy for part A. That's just part A. Find the density. There it is. Part B, after 3 hours of burning, the height of the candle is about 8.3 inches. Well, I'm in centimeters. How does this change affect the surface area and volume of the candle? Okay. Oh, I guess I don't need centimeters for this one here, and I don't even really need density. Okay, I'll go back to inches for this part here on part B. So we have the original. The volume one I could give you an answer for, as long as I know what 8.3 divided by 8.5 is. Surface area, I won't know. I'd have to do some more work. But 8.3 divided by 8.5, oh, it's a weird number. Anyway, you'd have to take a certain percent of the volume. It's around 97.6% of the volume. But we're just going to find the volumes themselves, right? Do I still have the paste job of this one? Yes, I do. Okay, so here's my original cylinder. I'm going back to inches because they reduced to 8.3, and I don't dare use all the decimals they had before. So the original volume, here's object 1 as it stands. So we have volume of object 1 equals, so area of, radius. Radius is 1.75 inches. That's half of 3.5. Yep. So pi r squared times height. Let's leave it exact. 1.75 squared times 8.5. 26.03125 pi cubic inches. Now, object 2 is going to take the same radius, but you now have a height of 8.3. It's not going to be much less. Remember, it's going to be 97.6% smaller. Not much, 8.3, and we do kind of the same thing there. So even in my calculator, I'm literally going to do the same thing. I just turn the 5 into a 3, and I get 25.41875. So 25.41875 pi cubic inches. So when I do volume 2 over volume 1, because they say the height of the candle is this, how does the change affect surface area and volume? So this is going to be, again, this one over this one. And it's literally going to be that number that I said before. It's going to be like 97.6. So if you look at the calculator, give me a second as I pop it up. When you look at the calculator here, I really got to clear my throat the right way. I did this divided by this and got this number. When I do this divided by that, I should get the same number again. So the previous answer divided by 26.03125. 03125. That 0.976. So same answer. Is there a good fraction of that? Oh, 83/85. Oh, duh. So 8.3 or 8.5. 83/85 of what it was before, around 97.6%. 97.6% of what it was before. Okay, that's how the volume compares. Surface area will be different because not everything is being reduced by that percentage. Okay, it was just height that changed. Excuse me. I was thinking, volume we should cube it. No. Anyway, surface area. Not everything's being changed by that percentage. So just the height is, but those circles stay the same. So it's not going to be this amount. It's probably going to be even smaller fraction, or like a closer to 1 fraction. It's going to be like 99% or something like that. So let's do the surface areas of both of these things, as I'm very low on room. So let's just go on the other side. And full disclosure, this probably doesn't matter to you, but after I finish number 7, actually, yeah, after I finish number 7, my whole video is probably going to pause. You won't know, you won't care. Probably something will be different in the background, but I have an engagement to attend to, and then I'll be back finishing the rest of the video. So whether I'm wearing different clothes or having something different in the background, or I sound different because it's later in the evening or something like that, that's just something to note. Anyway, so this is part B continued. All right, let's talk about surface area comparison. So surface area of object 1 is circumference. Was it 1.75? Circumference 2 pi r times height plus 2 pi times radius squared, 2 pi r squared, to area of both bases. So 2 times, 2 times 1 is that's 3.5. So 3.5, diameter times pi, duh. I should really lean into that more when I have it. Diameter times pi, so 29.75 pi. Plus, and then I got 1.75 squared times 2, 6.125 pi. So add those together. I get 35.875. 35.875 pi, that is square inches of original object 1 surface area. Surface area 2 is going to be slightly less. Now here's the thing. You have the same base areas, so I still get to keep the 6.125 pi about. The one difference is 8.5 turns into 8.3. So 2 pi times 1.75 times 8.3. So diameter was 3.5, right? 3.5 times 8.3. This is the one difference here. 29.05 pi instead of 29.75 pi. So 29.05 pi plus 6.125. And that's literally pi. That's literally 0.7 less. So I think this should be 35.175 pi square inches. Let's be sure. I'm not trusting myself all the time. Yeah, 35.175 pi. So, how does surface area 2 over surface area 1 compare? This should be closer to 1. This should be around, again, 98%, 99%, something like that, because only height changed while the circle stayed the same. 35.175 pi over 35.875 pi. Now, I'll figure out what the fraction equivalent is as well. I have no real guesses. Around 99%, whatever. 35.875 from the previous answer. So 98%, right? But as a fraction, 201 over 205. But around 98% of what it was. 201 over 205. Slightly smaller, not much. Interesting questions. I don't know, like, you know, for a lot of questions I like to kind of say, like, hey, like, what's your angle with it? You know? But this one is, you know, it is what it is. I don't really have an angle with it. They're just computing surface areas, right? All right, that's part B. Part C, and then after this, I'll kind of go on my pause. You won't care. Part C. How much mass to the nearest gram did the candle lose after 3 hours of burning? If this rate remains constant, estimate the number of hours of burning time the candle will have. Okay. The 3 hours was from this part B question. So, how much mass did the candle lose after 3 hours of burning? I would say that we take, this is a volume-based item, right? Whatever the volume was before, I mean, listen, we can use this number. The 83/85ths of what it lost 2/85ths. It lost 2/85ths of what it was before, right? 1 minus, whoopsie. 1 minus, because I don't want to use the rounded value. 1 minus 83/85ths equals 2/85ths. Lost of candle mass. I don't know if the word of should be there. Or candle mass lost, or whatever, right? So we're going to take 2/85ths of 1200. We're going to subtract that from 1200. So mass new after 3 hours is 1200 minus 2/85ths of 1200. That's the idea. The volume should be representative in proportionality with mass. However much you lose in one and the other is equivalent by percentage standards. So question is, what is 1200 minus 2/85ths of 1200? The answer is a weird number. 1171, approximately 1171.76 grams. Oh, it asked how much was lost, didn't it? Hold on. How much mass did it lose? So let's not do the subtraction. Let's just do the straight up 2/85ths of that number. It looks like it was around 28 or 29 grams or so. So mass lost, not mass new, mass lost. Sorry about that. Let's do it again though. 2/85ths of 1200. 28.24 about. 28.24 grams lost. Okay? So that's the first part of part C. Then they ask, where is it? If the rate remains constant, estimate the number of hours of burning time the candle will have. So here's the thing. I'm doing 1200 minus, now I just, I got this number here, but let's do the exact 2/85ths of 1200. I'm gonna write that as a fraction because I don't want it to stay like that. But I'm doing 2/85ths of 1200 to, oh, I already have that number. What's the fraction equivalent? That's, I didn't get the thing. Hold on. 2/85ths of 1200 as a fraction. 480 over 17. 480 over 17. We do this for a certain number of times, and we need to figure out when it equals 0. When does it equal 0? When am I out of mass, out of grams, or out of volume? You can say it whichever way you'd like to do it, but this is the way I'm going to go about it here. So, we solve this thing. 480 over 17x equals 1200. I multiply both sides by 17 over 480, by 17 over 480. Like that. And I'll get x equals whatever numbers this is going to be. Now, this number is the number of 3-hour increments that were done. That's not how many hours there were, but 1200 times 17 over 480 is 42.5. 42.5 3-hour increments. 3-hour increments. I was going to do a hyphen, but I did in the wrong spot. 3-hour increments. I got to multiply that number by 3. That's the way I see it. I have to multiply this number by 3 because these were 3-hour increments. It says number of hours. So I got to do that times 3. This is pretty robust as far as the problem goes. And I get 127.5. So 127.5 hours. That's my story, and I'm sticking to it. I'm not using any rounded values, so the exact values are as they should be. All right, guys, I am going to pause this thing. It's not going to matter to you, but I'm going to pause this thing, and I'll come back later in the evening. Hopefully everything is as should be. Okay, and I'm back. Might have been a blip for you, but it was several hours for me. So total wardrobe change, total everything different. Still baseball in the background because I'm a baseball nut. All right, guys, I'm going to keep moving forward here. Let's see where we last left off. We last left off with number 7. Did we answer C? How much? Yes, number of hours. All right, we ended up with number 7 here. I don't know. This 3-hour interval, multiplied this by 3, and then we got this number here. It had to do with the ratio of how much was being lost. Yeah, actually, yeah, here, let's go back to this problem just to make sure you understood what I did here. So on this problem here, the amount of volume, that this percentage here, right, 83/85ths of the volume remains after the candle melts from 8.3 inches to 8.5, from 8.5 to 8.3. So you lose that fraction of your candle. You also lose that fraction of its weight. And there were 1,200 grams of weight initially. So that was its initial mass, 1,200 grams. So you lose 2/85ths of that each time. 2/85ths of 1,200 is also represented as this. So these are equivalent to each other right here and right here. But if you lose this X number of times over and over, basically what's that X that you do till it reaches 0? That answer is approximately 42.5. Now, 42.5 is the number of 3-hour increments that had gone by. It says every 3 hours of burning, it loses 0.2 inches, basically. There are other ways we could have done this right here. We could have said burning time the candle will have. Yeah, it's just until it has 0 mass there, right? So you multiply that thing by 3, and then you get number of hours. So that's how that one worked out. All good. All right, let's move on to number 8. Sketch a 2-dimensional shape and an axis of revolution that forms the water container shown. Well, I can copy and paste that water thing. I know maybe you can't. I want to at least get the idea of it and just give you the drawing, right? I will trace around it, and then I'll kind of do it probably in a standard way, or at least show you the standard version. So number 8, here's our water container. This thing is revolving around a vertical axis of revolution, right? If I could stick a rod right through the center of the water thing, this would be our axis right here. And then it's revolving around. So I can do a 2-dimensional solid on one end of this. Just trace around it, right? Here's the idea. And it revolves around this where everything's circular around that thing, right? So whatever I draw here would be the equivalent. You'd be drawing the same thing. You might not trace it. I just want to get more of a perfect version of answer, or just a very decent, a good-looking one. And then say, hey, if you drew something like this, good on you. I know I wouldn't do anything perfect. Ooh, I kind of messed up at the bottom there. But yeah, this would be our... That would be what you want, right? That's your drawing. Like, that's your answer to that thing. I know I totally cheated. I totally did. I understand that. My axis, let me draw lines on it. That's my axis of revolution. That's number 8. All done. Sorry about that. Number 9. Just do what you can there. But the axis, basically, it's a vertical axis there, and it revolves around that to make the water thing. Number 9. A circular region with a 3-mile radius has a population density of about 1,000 people per square mile. Find the number of people who live in the region. Is this our first? Okay, this is our first one with the circular region. We had a couple on the review, I believe. So, 3-mile radius, that gives us an area, right? This is about population density. Oh, by the way, this would have been section 1.4, and this is section 1.1. So, on this number 9, let's start with the density. Density is 1,000 people per square mile. Area is circular region, pi r squared, which is 9 pi square miles. And we have the correct units to find people for population. Density is population over area. So 1,000 equals this population, unknown, over 9 pi. If you multiply both sides by 9 pi, you get a population of 9,000 pi people. We all know what that is, right? I don't know, it's around 27,000 something. So 9,000 le pi. 28,274. 28,274 people. Find the number of people who live in the region. Yeah, about that. Okay. So, yep, that's what we do, right? Set it up with that same thing, right? Same thing that you're going off of there. density is, always set it up with that. Set it up with a formula that you know how to do. Don't try and trick yourself into messing up after that. Number 10, sketch and describe the solid that is produced when the region enclosed by that equation, that equation, that equation. That equation is rotated around the y-axis. So I'm going to do a copy-paste. I'm going to give you guys graph paper for this thing. We will do the following lines. We're going to do y equals, maybe I should write this down first. Hold on. I was getting my line set up. We'll do y equals 0. That is the x-axis. We'll do y equals, hold on. Y equals negative x plus 8. That's a slope of negative 1 and a y-intercept of 8. So from here, I can go down 1 over 1. So it's going to cross through 8, negative 8 right there, and positive 8 right there. Boom. We have x equals 0. That's the y-axis. I know that still tricks people to this day. Boom. And x equals 5. So x equals 5 is this guy right here. I'll just draw it. So x equals 5. Now this region, we're going to rotate around the y-axis. So this is an interesting one, right? This is this guy here, and I'll just go ahead and solidify it now, and then I'll delete the lines. So this one right here, oh, okay, it's a cylinder with a cone on top. So let's delete the blue lines. I'll thin that out, but I'll shade it in. Actually, I don't have to shade it in, but I'll thin it out a little bit. All right, there's that guy. We're going to revolve this around. Let me thin it out in full. Sorry about this. There we go. Okay, we're going to revolve this thing around the y-axis. So the y-axis is this guy here. It's our axis of symmetry. Let's go 5 across here. Make it cylindrical. Whoops. Same thing right here. And it goes up like that. And I can connect that here. And then I have this triangular shape guy. And that's basically the rotation that I get to do, right? That's kind of it. This thing will connect right here. That 8 and down to there. So there it is. It's a cone. Oh, here's the backside. There we go. It's a cylinder with a cone on top. What are we going to find? The volume of the solid. Did we have to name it or anything? I'll describe it. So it's a cylinder and a cone. If I say cylinder plus cone, that kind of gets you the better idea that we would add those two volumes together. Now, the cylinder and cone both share the same radius. The radius is 5. It goes from some center, like even this one, outward like that. It's got a radius of 5 units. The cylinder's height looks to be 3 units. And we're finding volume. The cone's height, you have to remember, its center is right here at the, oh shoot, what's that at the 3, right? Boom. So it goes from 3 up to 8. The cone's height is 5 units like that, right? That's where it goes from. So cylinder, the height, call it object 1, I suppose, is 3. And the cone's height, object 2, is going to be 5. Okay. Object 1, object 2. In finding the volume, we'll add both of their volumes together. Okay, volume of object 1. Volume of object 1 being the cylinder is area of base, pi r squared, times height, which is 75 pi square units, cubic units, excuse me. Volume of object 2 is 1/3 area of base times height. Those are 5, right? Yup. Still the radius there. 125 thirds pi cubic units. And then, I don't know, do you want an exact answer? 75 times 3 is 225 thirds. So volume of total, we're going to get, so 75 pi, that's 225 pi over 3. I bring that up because I'm getting a common denominator. So 225 thirds pi plus 125 thirds pi, excuse me, equals 350 thirds pi cubic units. And I can't get to my calculator. Use my calculator. 350 thirds pi. I'm getting 366.52 about. 366.52 cubic units for that entire composite solid that we're looking at there. Okay, so we have both the cone and the cylinder added together, and we get that. And that was number 10, right? That was the very last question that we had from the chapter test portion. Now what's going to come up after that, y'all, is the cumulative assessment. Now, cumulative assessment, as I've kind of said before, is a little kind of a misleading term because we've only had one chapter. So everything we see is going to be based off chapter 1. But as we build up over time, cumulative assessment will jump into chapter 2 and chapter 1 together, and chapter 3, 2, and 1 together, and things like that. And it's kind of random. They do different kinds of things with these questions. Sometimes they have multiple choice and matching and in-depth things like that. But I'll keep it as part of the same video. Just check out the description section if you want to find anything in particular. You should have found this one specifically. But I'll go and move forward. I'll even wipe this slate clean right here. Let's get started on this new set with number 1. Identify the shape formed by the intersection of the plane and the solid. Now, this would have been out of section 1.3. I don't know if I was identifying things anymore, but this is out of 1.3. So part A, B, and C, I'll just kind of name them as we see them. So part A, the plane is intersecting with the trapezoidal prism parallel to the bases. It makes indeed a trapezoid. Part B, you see a pentagonal pyramid parallel to its base, where that one's horizontal with it. It makes a pentagon. We're looking at basically the purple shape. And then part C, you have it going vertically. Well, it's vertically through this triangular prism, but the triangular prism's knocked down, and it's not giving you the triangle. It's not parallel to the bases. It's going through them. It makes that rectangle. That one's a rectangle on part C. So I always like to refer to their drawings for you because they give that great basis of the vision, the appearance of the 3D-ness of the shape, and I think it works out perfectly. All right, that's number 1. Let's move on to number 2. About 19,400 people live in a circular region with a 5-mile radius. Find the population density in people per square mile. So if you just came off the chapter test portion, we did something where we found the population. This time density is population over area, and we have both of those. Population, 19,400 people. Area, this is once again a circular region, so pi r squared. Pi times 5 squared, or 25 pi, square miles, and we need people per square mile, so we're set to go by dividing one over the other. 19,400 over 25 pi. Now, when I use the calculator in this scenario, I want to make sure 25 pi is in parentheses, so I'm going to go ahead and do exactly that. 19400 divided by 25 pi. And I'm getting 247 about. So about 247 people per square mile of density. Okay? That's number 2. Number 3. What is the volume of the solid that is produced when the region enclosed by y equals 0, y equals 3.5, x equals 0, and x equals 8 is rotated around the x-axis? Now, it's a multiple choice question, but we still really got to do the work to bring it in. So let's do number 3. Hopefully the last thing I copied and pasted was the graph, because I'm going to hit the paste button. There it is. All right. So let's get those several equations. We have y equals 0. That's the x-axis. Hold on. Okay. That's the x-axis. I need to get my arrow tool thing set up again. Blue. Okay. We have y equals 3.5. Interesting one. It's a horizontal line between 3 and 4. Maybe one more click down. Okay. Y equals 3.5. X equals 0 is the y-axis. That's not the y-axis. And x equals 8. So this is a rectangular thing that we're going to be rotating. X equals 8. So that region that's bounding it, we're going to rotate around the x-axis. So our region, I wish I could just pause. I wish I could just go faster talking about this stuff, because I go kind of slowly through these. Of course, you're probably drawing and playing catch up, but our region is this rectangular portion. Normally I shade it. Now I'm kind of doing more of the deleting the lines that make them. So I can, I should have just done the rectangle tool, of course, duh. I didn't. The x-axis, though, is my axis of symmetry that we're going to rotate around. So this guy right here. So we're going to make a cylinder. Okay, it's going to look like, is that blue or black? I think that's black. So it goes 3.5 up. I got to go 3.5 down and circular around it because we are making a cylinder. Which way? Is that the bottom? So if that's the bottom, then this is the top. And I'll make that one see-through. There we go. Okay, so we have a cylinder from those things. I forgot to write x equals 8 around x-axis. What do we have to do? What's the volume of the solid? So it's a cylinder, right? This cylinder has a radius of 3.5. R is 3.5. That's what that's doing there. And we go from 0 to 8 on that, so the height is 8. Remember, height of a prism or cylinder is the distance between your bases. So your volume is area of base, pi times radius squared times height. Now, 3.5 squared is 12.25. And 12.25 times 8, and there's pi still. 1, 2, 3, 4. Got 49, 90, 98 pi. 98 pi square unit, cubic units. I keep saying squared. Cubic units, and we have to round that. If I'm going to guess, it's probably going to be B. So let me try and do 98 pi on my calculator there. 307.876, 307.88. Yep. So volume's about 307.88 cubic units. And I always question, not always, but I do wonder what all the different answers are as far as like, hey, how can we get them? If we don't multiply by pi, if you find surface area instead, if you take a third of something, I wonder where these answers could be obtained, but that answer there is going to be B. Okay, number 4. You are vacationing at the cottage shown, and after arriving, realize you need to increase the inside air temperature. To raise the temperature to your desired level, you need 7 BTU. I forget what that stands for. British temperature units. I forget what it stands for. BTU per cubic foot. How many BTUs do you need to raise the temperature of the cottage? I hope I don't need any actual conversions of things. I hope everything is stood within here. Kind of sounds like a density thing, but it also sounds like a rate. You're vacationing, the cottage shown arriving. To raise the temperature to desired level, you need 7 BTU per cubic foot. How many BTU do you need to raise the temperature of the cottage? So, really, it's just you need to fill out the volume of the cottage. And all of them BTUs need to be applied. You can kind of refer to this as like mass, volume, all that kind of stuff, density. BTU is kind of your mass this time. So yeah, we can kind of work it out that way. Let's just begin with volume as a whole. Now, what we have for this house, I wonder if copying and pasting is the best way to do the job. But as far as this house goes, we have a rectangular prism as well as a triangular prism. Don't confuse it with a pyramid, right? What we have on, I guess I don't need it that big. What we have in this scenario, maybe I'll transparently draw it first. You know, I'll draw it and then I'll drag it out. But what we have is a rectangular prism down here with a certain length, width, and height. We have the same length and width of the, well, I take it back. It's a triangular thing over there. Let me kind of get this thing traced out, and then I'll get rid of the house itself, or I'll move it to the side and label it. Okay, so we have this guy here. We get some dotted lines going, brewing. We have this guy here and this guy here. Yeah, a lot of good action here. Maybe I could have just made it myself in a different way, but I want to keep these intact the way that I had it. Ooh, kind of rough on that bottom end. Okay, so if I get rid of the house, or at least move it, because I still want the, yeah, I'll get rid of it. I still want the measurements that I had from before. Doesn't that look cool? So remember, there's a rectangular prism, but that's a triangular prism. That's not a pyramid. So the triangle bases are here and here. That means we want this to be our height. Same with the rectangular prism. Maybe keep that intact the same way with regard to height. So on the triangular prism, height is 28. If you look at that thing on the bottom, 28 feet, I'm going to call that one 28 feet as well. So I'm going to make this my base, this my base, this my base, and this my base. I could essentially rotate this thing over if you really wanted to. But a 28-foot height with regardless of whichever way you put it there. And then I have a 10-foot, this guy here is 10 feet, which is important for the triangle's area, right? This whole 1/2 base times height thing. And then you have a 20-foot guy right there, and then 8-foot guy right here. And remember that 8 feet, that's a part of my base of my rectangle. So I have two objects, calling it object 1 and 2. Let's find the volume of object 1 first, actually, the triangle. So the triangular prism. That's area of base times height. We have a 20 as for the triangle itself. We have a base edge of 20 and a height of 10. So 1/2. Sorry, let me do this again. Base area of base 1 is 1/2 base times height, base length times height, which is 100 square feet of that triangle base. That's this guy here. The height of the triangular prism is 28 feet. So height is 28 feet. So the volume of object 1 is area of base times height, which is 2,800. No pi. 2,800 cubic feet. So there's item 1. Item 2, area of base there. I'm going to call this 8 by 20. Okay, I'm going to call it that and just keep the height as 28. Just kind of keep it consistent. So 8 times 20, which is 160 square feet. And then with the height being 28, volume of object 2 is area of base times height. I don't know that number, so let me get that. 160 times 28. So that's 4,480 cubic feet. So the volume of the total is going to be 2,800 plus 4,480, which is 7,280. 7,280 cubic feet. That's the volume of all of that. That's where we need to work out the whole per cubic foot aspect and how many BTUs we need to raise the temperature of the cottage. So this can kind of work as a density equals mass over volume thing, distance is rate times time, whatever. That 7 BTUs per cubic foot means we need to multiply the amount of BTUs by 7. Excuse me, the amount of cubic feet by 7 to get the amount of BTUs that you need, right? 7 BTU per 1 cubic foot times 7,280 cubic feet equals this number of BTUs, right? That's where the cubic feet cancel out. You're just left with BTUs. So how many BTUs do you need? 7 times 7,280. And that'll be, and again, I forget what it stands for. Maybe it's British thermal unit. That sounds more fitting. 50,960 BTUs would then be that answer. So finding the volume, multiplying by that 7, because there's still a rate that's applied, would then be that final result. Okay, there's number 4. Let's go to number 5. Marble has a density of 2.56 grams per cubic centimeter. I did not know that. So density equals 2.56 grams per cubic centimeter. What is the mass of the cylindrical portion of the marble pillar shown to the nearest kilogram? So if you notice, they did state cylindrical, and it kind of looks like it. You'll notice that this is also in inches, and they give us a diameter. So we're going to have to do some conversion practice. I think this also happened in the chapter, maybe the chapter test portion. I think we were just involved with that. So we're going to convert these ones to centimeters as well. So 1 inch is 2.54 centimeters. I'm going to have to do some of that work on the side over here. So multiply 14 by 2.54, multiply 115 by 2.54. So 14 times 2.54. The reason I'm converting centimeters is because density is in cubic centimeters, so we have to work it out that way. So this is 35.56 centimeters. And remember, that's the diameter. We still need to probably find the radius when it comes to cylinder's volume and stuff. 115 times 2.54. And not to confuse it with this 2.56, right? That's really close to 2.54, but completely unrelated to what I'm doing right now. 292.1 centimeters. Those are exact values. Now, that's the diameter. If the diameter is 35.56, the radius is half of that. 35.56 divided by 2. I think I know. I just don't want to be wrong. 17.78. Okay. we got density, we're going to get volume, and then we can get mass based off that. Volume is area of base, pi r squared, times height. Like that. I'll go straight into, well, I want to keep it exact actually right now. Let's square that answer times 292.1. And I have an exact one, or as exact as I can get it written, 92341.10564 pi cubic centimeters for volume. We have that kind of exactish one. Density equals mass over volume. We're going to find mass to the nearest kilogram. Now, our thing is currently in grams. To do kilograms, ultimately, we're going to divide it by 1,000. Okay? So density is mass over volume. 2.56 equals mass over, I'll write the shorthand, 92341.1 pi. I'll still use the exact one here. So mass, we're going to multiply, multiply both sides by this guy right here, 2.56 times that. That'll get mass by itself. So I need that number times pi. I'm going straight to times pi. And times 2.56. We're getting about, kind of big number, but we're going to get into kilograms after. So we're going to get about here, because this is in grams, 742,651.2361 grams. If I go and divide that by 1,000, that's a decimal shift 3 places over, get 742.65 kilograms. 742.65 kg. That's where I'm going to stop my rounding there. And that will get my final result based off all that stuff. So volume alongside density and stuff gets me where I wants to go, right? Okay. They said to the nearest kilogram. So let's go 743. I always got to check. I'm like, I got the units right, but not the rounding. Right? That's the part that, that's the part I really got to pay attention to. Okay. Number 5. Let's move on. We got 4 more questions, I believe. Number 6. The rectangular decagonal pyramid shown is intersected by a plane perpendicular to its base. The plane passes through its vertex, so it's divided into 2 congruent parts. What's the shape of the cross section? It's going to be a triangle. So if I go vertically through, I'll just do the sideways version. I'll use the rectangle shape and go like that. So if I go through, whoosh, right through the middle like that, and it's hitting, say, that triangular, I want you to see it kind of hit the triangle part. It's hitting the triangular portion, like that. Then, yeah, I'm hitting that there, and then my cross section is this guy, right here. It's going on the ins and outs there, and I'm getting that triangle. That's all. I can't really get a lot more visual with you on this one, but that one is a triangle. Let me see the other options. It said perpendicular to its base. If it said parallel to its base, listen, the answer would be a decagon. But it didn't say that, so it's not it. I don't know where rectangle or trapezoid would even fit for this configuration there. All right, number 7. That was a quick one. Number 7. You designed the ramp shown. Nice. The outer surface of the ramp, including the bottom, is covered with plywood, so the bottom is covered. Okay? Your friend wants to double the base and height of the triangular sides of your ramp. Your friend claims the new ramp will use no more than twice the amount of plywood as your ramp. Do you support your friend's claim? Explain your reasoning. You are going to use 4 times as much. Now, because you're doubling 2 different dimensions, you're going to use 4 times as much. However, they want us to talk about surface area stuff, so we're going to do so. This is, and I'm not going to trace it, I'm just going to draw another one. This is a triangular prism. The triangle here and the triangle on this side here are your 2 bases. This is a right angle. They even show you as one. This is 2.5 feet. This is 6 feet. These 2 alone make the base and height of your triangular base. This is the height of your prism. This 8 feet right here. So when it comes to surface area, it's surface area. So hold on. Surface area. Wait. It's not volume. We still need area of the bases, but we got to talk about surface area of the prism. So surface area of a prism is your lateral area plus the area of both bases. Let's start with both of the bases. And by the way, this will be object 1 before we do any doubling or any sort of that. Object 1 base area, I can indeed do 1/2 base times height, the 6 times 2.5. Half of 6 is 3. 3 times 2.5 is 7.5. So we get 7.5 square feet of base area. Doubling that, 2 of those is going to be 15 square feet. There's my base area for that triangle. Now, this part here, the lateral area are the 3 faces here. 1 on top, 2 on bottom, 3 at the back end. So there are 3 of those. In order to find lateral area, the quick hand notation, it's perimeter of this base times the height. So lateral area, again, lateral area is perimeter of base times height. But to get perimeter base, we need this third side. I'll call it x. We got to use Pythagorean theorem to find that x. We got to get 2.5 squared plus plus 6 squared equals x squared. And I'll tell you what, this is part of a 5, 12, 13 Pythagorean triple. This is half of 5. This is half of, if I double this, I get 5. If I double this, I get 12. If I double this, I get 13. So this number is going to be half of 13. You can use Pythagorean theorem if you keep going, but that number should be 6.5. So x is going to equal 6.5 feet. I'm going to go short end if you know your Pythagorean triples. That's one of them. So this is 6.5. Let me write it. You can continue your Pythagorean theorem. You should get 6.5 as well. Exactly, by the way. So lateral area of object 1 is perimeter of base, 2.5 plus 6 plus 6.5 times height of prism, that's 8. It's the height of the prism. So 2.5 plus 6.5 is 9 plus 6 is 15. 15 times 8 is 120. So 120 square feet of that. You have 2 bases at 15 plus your lateral area, which is 120. 15 plus 120 is the surface area of the whole thing, which is 135 square feet. That's object 1. Object 2 would be what your friend's going to do. New ramp, your friend wants to double the base and height of the triangular sides of your ramp. Those are technically the bases. So we're going to double 6. We're going to double 2.5. And that gets you that 5 and that 12, by the way. So let's redraw that one more time for object 2. So object 2 has triangular here. Pretend like it gets doubled. I'm not really drawing it to scale. So this 8 stays as an 8 right here. This is still 8 feet. But now we doubled 2.5 to get 5. We doubled 6 to get 12. And here's that straight up 5, 12, 13 Pythagorean triple. We're going to have to use that 13 again when we do what we do later for the perimeter. So area of base 2 is 1/2 base times height, 1/2 of 12 times 5. That's half of 60, which is 30 square feet. So 2 bases is going to be 60 square feet compared to the 15 before. That's the thing that got 4 times bigger. That's the thing that got 4 times bigger. But I shouldn't have said everything gets 4 times bigger because the lateral area does not. So I take back what I said. Let's actually compare this. We still got to figure out the lateral area of object 2. Lateral area of object 2 is perimeter of base. Oh, these parts do get doubled. Maybe it still does. I gotta think in terms. No. Anyway, perimeter of base 5 plus 12 plus 13 times the height of 8. 13 30. 30 times 8 is 240. 240 square feet. So now we're going to have surface area of object 2 with 240 plus 60, which is 300 square feet. Clearly not twice as much. Actually, it's not bad. 135 doubled is 270, but it's not double. You'll need more than double the plywood. How much more? 300 over 135 amounts. And let's do that. .2 repeating, so 2 and 2/9, which is 20/9. Let me make sure of that. Yeah, 20/9. 20/9 times more plywood. 122% more, etc. It says explain your reasoning. I mean, my math's my explanation as I do those things, but the general idea is that not only one thing got doubled, and because it's surface area stuff, it's a little more complicated. I think it's worth calculating that surface area to do it. So I did, and that's what we got. Okay, let's go to number 8. Which figure has the greatest volume when it's rotated around the given axis? We might have to find all 4 volumes to answer that question. So let's copy and paste these guys. Excuse me, or I will copy and paste these guys. Probably going to go pretty fast with the calculation since I got to do 4 of them. But on part A, we make a cone. Excuse me, we make a cone. I ate as a part of my engagement that I had. It's a pretty big steak. I love my steaks. All right, so we make a cone. Okay, the radius is 5. The height is 8. We're comparing volumes on these ones. So volume is area of base times height. Oh, 1/3. 1/3 area of base times height. 8 times 25 is 200. So 200 thirds pi. Let's leave it like that just for a moment. If I need to do later calculations, I will. Cubic units. Okay, there's A. Let's go to B. Now 200 thirds is close to pi is close to 66 pi. Just so you know. B is an interesting particular kind of drawing, but because you have the same thing on top and bottom when it comes to this cone thing, I think we'll be fine in terms of calculating that volume. We just got to double it. But yeah, it's kind of 2 cones. Radius of 4, height of 6 for each of them. They're just right on top of each other. So we have that. Right, get it? Okay, so with that one, we have volume is 2 of these things. 2 of the 1/3 area of base times height, like that. 1/3 of 6 is 2. 2 times 2 is 4. 4 squared is 16. 16 times 4 is 64. So you get 64 pi. Now remember, this number was like 66-ish pi, so this one's already winning. I might have to come up with what the things are, but so far A is winning. All right, here's B, and A is in the lead. Part C, you have a sphere. And listen, I don't know the answer to the question. I can't even eyeball it and go, well, maybe. I'm going to have to let it do its thing. Let me copy it with the part C in there. And I'll shrink it to size. All right, part C. We're going to make a sphere out of this guy. 3.8 is our radius. And a sphere's volume formula is different than a cone's. So volume for this guy is 4/3 pi r cubed. And I don't know if this is bigger or smaller. 3.8 cubed times 4 is 219.488. So this is 219.488 thirds pi. Now this is more than A. C is winning because these are both divided by 3, right? So C is winning. 219 is more than 200. So that's in cubic units as well. But now C's got the lead, and I didn't know whether that would work or not. And D. D's rotation, or revolution, whatever you want to call it, is going to be a cylinder. So on D, we got ourselves a radius of 3.4 for the cylinder, and the cylinder's height is 6. So that's what that one's kind of looking like, yeah? So this is, let's move it over. Hopefully my work is organized for you guys as far as what I'm doing. This is volume equals area of base, pi r squared times height, 3.4 squared times 6 is 69.36. Okay, I think I officially now have to compare these multiplying by pi. So 69.36 times pi is 217.9 about. So 217.9, I believe this gets second place. So 217.9 is D. This one, 219, and this was an exact number, 219.488 over 3 and times pi. That one is 229.847. So this one I think wins. 229.85. When you don't know, guess C. Cubic units for C. Volume of C, volume of D, volume of B, and volume of A. B, I think, loses 64 pi 201.06. Yeah, that's on the back end. And A is like third place or whatever. So 200 pi 209.44. Okay, so ranking from biggest to smallest, we got C, D, A, B. So C, D, A, B. C is biggest. C wins. Greatest volume. The sphere. It rules the world. Last question here is number 9. A silo similar to the one shown has a height of 60 feet. Hold on, let me see if I have enough memory on my computer right now. Running near the end. Hopefully this one's kind of a decently quick question. A silo similar to the one shown has a height of 60 feet and a diameter of 18 feet. Oh, the silo. I'm like, this barn? That's not circular. Okay, so that looks cylindrical. It is filled with a grain to a height of about 30 feet. How many bushels of grain are currently in the silo? 1 bushel of grain is about 1.25 cubic feet. Okay, so we have a cylindrical silo. It's got a height of 60 feet. It speaks of diameter. Honestly, I only care about radius, but I'll go and give you diameter as well. So diameter is 18 feet, means a radius of 9 feet. Right? So this is kind of a volume-based question, I believe. It is filled with grain to a height of about 30 feet. So halfway, about, is what they say. So 30 feet. How many bushels of grain are currently in the silo? 1 bushel of grain is about 1.25 cubic feet. I'll tell you what, it doesn't matter how much the silo is height-wise. It just says how much it's filled up to. That's all that matters. So I honestly don't think we care about the 60. I care about the 30, and I don't care about the 18. I just care about the 9. So the volume of bushels in the silo is going to be that, they really fill up the space about. So pi r squared times height. 91. 9 squared is 81 times 30 is 243. 2430 pi cubic feet of that stuff. Now we have 1 bushel of grain is 1.25 cubic feet. So 1 bushel equals 1.25 feet cubed. So actually, I'm set up as a proportion because I want you to know whether you're multiplying or dividing here. So 1 bushel, 1.25, actually not a proportion, but I'll write it as a ratio. And then you multiply by this many cubic feet. And then you can see that what happens, although these cancel out here, you're going to divide this by that. So 2430 pi divided by 1.25. You could also set it proportion-wise. And we're getting, and I'm using pi with this, so it's around 6107 bushels. There's a decimal, it's like 0.25 something, but around that many bushels. How many bushels of grain are currently in the silo? That's the answer that I am going with. I think that they wanted that kind of number, right? I don't think they wanted weight or anything like that. All right, guys. So that ought to do it for this one. This is Mr. Robinson. Thank you so much for watching. And this closes off Chapter 1 as a whole. Coming up next will be Chapter 2 and 3. And we keep going to things much more algebra-based now. This was geometric modeling. Ditching that a little bit more. A little more graphs, a little more algebra, solving polynomials, things like that. Get ready for it. But this is it for now. Guys, take care. Thank you. I will see you in the next one.